Hello everyone, once again to another one of my Jake the Tutor math videos, and we are going to pick up where we left off last time, where we discussed horizontal and vertical shifts. We just finished up the horizontal shift part, and now we're going to do some reflecting across the x and y axes. So, first thing we're going to do is we're going to have to start out with a function to shift with. So I'm going to say we're going to call this f of x is, we're going to use a line we're kind of familiar with by now, and I'm going to use 2x, but we're going to shift it to the right. I'm going to say to the right 3 units. So if you recall from the previous videos, to do that you would do 2 times x minus 3 to go to the right 3 units. So to draw this line, this means it's going to be the regular line of 2x, but it's going to go to the right 3 units. So it's going to cross at the point 3 comma 0. And if I can get the draw menu to come up, that would be great. Okay, so it's going to cross right about here. Oops. And it's going to have a slope of 2. And we'll say it goes right about here. And we can extend it down this way as well. There. Alright, so there's our line. And I guess it's kind of labeled. So now if we want to, let's say we want to kind of reflect this line across the x-axis here. So we want to kind of mirror this image across the x-axis. So it'll look something, let's make it red. So now the line will still hit the same place on the x-axis, but now it's going to be going in this direction instead. Easy, does it? Looks good. Alright, so there's the line we're going for here. Let's call this line g of x, as we've kind of been doing in our past videos. So there's g of x. So we want to go from f of x to g of x, and we want to know what we have to do to f of x to get this line here. Well, what we have to keep in mind here is that on the g of x line, all the values, so like all of the f of x values are going positive from this point on, and now they're going negative, and all the negative values that were on f of x are now going in the positive quadrants of the y. I guess with respect to y. So what this tells us here is that g of x has turned all of the f of x values that were positive into negatives, and all of the negative values into positives. So that's as simple as a sign change. So, and in fact we can prove this if we take a few example points. So on f of x we have this point looks like one spot it hits, this point as well. Why did they all just disappear? That was weird. Alright, so there's those, and similarly these correspond to the points on g of x that at the same x values. So we know that so on f of x, when x is equal to, this looks like 4 and this looks like 5, so when x is 4, so f of 4, we can find out what that equals. If I can find out where my cursor went. Okay, here we go. This is 2 times 4 minus 3. And of course, that's just going to be a 4. So 4 minus 3 is 1, 2 times 1 is 2. Easy enough. And so f of 5, similarly, is It's going to be 2 times 5 minus 3. And that's going to be 2 times 5 minus 3, which is 2. So 2 times 2 is 4. And we can see that clearly on the graph. So here's 2 and here's 4. When they, head back to the y-axis, we can see that's where they hit. On the other hand, g of x, when we use g of 4, we can look on this graph and see that this hits at -2 instead of +2. So we know that g of 4 needs to equal -2. So, or so we know this equals -2. So all we have to do is just negate the entire function of f to get -2, because we also know that g of 5 will equal -4. So that we notice that f of 5 is 4, and then g of 5 will be -4, we realize that all we have to do is just multiply all this by -1 to get this. So g of 4 is going to look like this. It's going to look like -2 times the quantity of 4 minus 3, and this will equal -2 times the quantity of 5 minus 3. So all we did is we basically just changed the slope of this line from a positive slope to a negative slope. Pretty easy enough. So that's for flipping or reflecting across the x-axis. So in summary, I guess I better draw a summary here. So what am I trying to say here? So negative f of x reflects the graph of regular f of x across the x-axis. Alright. And so we see, and so I guess just as a summary here, we find out that g of x is equal to the negative of f of x. So that's all there is to it for reflecting across the x-axis. You take the function you're given, or the equation you're given, you can just put parentheses around the whole thing and then put a negative sign up front. And that's how you get a reflection across the x-axis to transform your graph. So I'll just stop the video here, and we'll pick up on reflections across the y-axis. So until then, I'll see you in the next video.